Okay, this is Third Rock from the Sun. This is video 4, and this one is just going to be about volcanoes. So we're looking at a diagram now showing the plate boundary lines and then the active, repeatedly active volcanoes, the most recently active volcanoes, the ones that require further study. Notice that the vast majority of them are all on plate boundaries. There's a couple more. The only ones that are not are those hot spots that we talked about in the first video. Okay. So volcanoes are located at plate boundaries and at earthquake zones. Hopefully we're getting the picture now that the reason they are is because that's where the stress in the earth is moving, so that's where the magma will come up and create those volcanoes and those eruptions. They result in extrusive rocks and pyroclastic rocks. Pyroclastic is particles that are thrown into the air during eruption. They settle and form ash, tuff, and agglomerates. So that's really essentially different forms of dirt and gunk. From like the ash, like the really fine powdery stuff, to an agglomerate is the bigger rocks. So pyroclastic is the stuff that's thrown into the air. Magma is the stuff that it comes out in liquid form. It's extruded to the surface in a liquid, and then it forms the extrusive igneous rocks. For example, rhyolite, and andesite, and basalt. And those, as they cool off, turn into the rocks. So it starts as lava, and then it turns into the rocks as it cools off. If the lava is really acidic, it's very viscous and in very poor flow. If it's more basic, there's more fluid in it, so it flows faster, flows better, so that the slope doesn't have to be as high for it to continue to move. So it'll continue to move over, like a relatively small hill as long as it goes down. So it spreads over a whole lot more area than an acidic flow. The basic parts of a volcano are the crater. The crater is the depression at the summit, the top. It's connected, there's a vent or a pipe to the magma chamber below. Has to be some way for the magma to get to the surface. The caldera is a crater that's more than 1 kilometer in diameter. It's formed at the top of a volcano after the lava has drained from the underground magma chamber. So it essentially causes, there's so much pressure from the lava from the underground stuff that it's all built up at the top, too much weight, and that causes the summit of the volcano to collapse. Not enough support, and collapses. The pit crater is a collapse on the flank or the summit. It's smaller than the main caldera. The vent is the conduit, the area where the magma moves from inside the earth up to the surface. And fumaroles are secondary vents on the flanks. They emit steam and other gases. Okay, so a diagram to make sense of everything that I just said. You have the magma reservoir underneath. You have the conduit, that's the main flow. You have the fumaroles coming off to the side. And then you have the crater right here. The summit is the top of the volcano. Once all this magma comes up and collapses all this will turn into a crater. And then you have your side craters, and again you would end up having your calderas, your crater, I'm blanking, sorry guys. The craters that have opened up on the side of the volcano. Okay, so the different types of volcanoes, you have a shield volcano. That, for example, the Hawaiian volcanoes are shield volcanoes. They have what's called docile lava outpouring, which means that it's relatively not scary, for lack of a better word. It's you have lava moving out, it's pouring out, but it's not exploding out. There's very minor pyroclastic material. The lava kind of bubbles up at the top and then runs down the side of the volcano. It doesn't, spurt out into the air or get thrown great distances. The lava makes a great big dome with that central crater on it with the opening. Slope is somewhere between 2 and 10 degrees, like a flattened shield. They're very long-lived, lots and lots of lava. the Kilauea volcano in Hawaii is your example of that. Mauna Loa, the Big Island of Hawaii, is the largest active volcano in the world. Last erupted in 1984, 14 times in the 20th century, 37 times since 1932. Most massive mountain on the Earth. Elevation is 13,677 feet above sea level, and then 31,000 above the seafloor. And the huge, just massive 10,000 square mile, cubic mile of volume. It's crazy how big this one is. Cinder cones is the next type of volcano, and these are the ones that erupt a lot of pyroclastic materials. So they have a whole bunch of stuff that's spitting out at the top, a lot of ash, a lot of smoke, a lot of rock and stuff, half melted lava or half solidified lava that erupts and is thrown out of the top of that crater. Very steep slopes, 30 to 40 degrees, because there's not a lot of lava coming down the side of them. These are not very long-lived. They tend to be, get rid of all that extra stuff and be done. Usually relatively small because they're not having that lava to form a whole lot of extra mass, volume to them. They're often found parasitic on larger volcanoes. The Sunset Crater in Arizona and the Paricutin in Mexico are examples of that one. So you can see that picture of one there. So you have the main crater here, and then the cinder cone over here. Composite volcanoes erupt both lava and pyroclastic material. The slopes are intermediate. The lava acts as a protective coating, and then the pyroclastic stuff layers inside that. These build up over a long time. They're the most picturesque, but they're also the most violent. They're the ones that have the really crazy eruptions with lots of lava coming out, lots of pyroclastic stuff spitting out the top. Mount Vesuvius, Mount Shasta, Mount Fuji, and Yellowstone, all examples of composite volcanoes. And there's your picture of that there, a nice big crater at the top. The Yellowstone caldera, you can see here. Okay, so eruptions from volcanoes, they may produce ejecta, which is a lava rock or ash, molten lava, and toxic gases. So there's a lot of stuff potentially coming out from them. The gases they release: water and carbon dioxide, sulfur oxide, and hydrochloric acid. They occur when pressure within the magma chamber builds up, that forces that magma up through the conduit and out a vent. The benefits: you get new land, a lot more mineral that comes up from inside the earth, and a lot more nutrients from that broken down lava. Okay, in 1980, May 18th, Mount St. Helens erupted. It was the most destructive in the history of the U.S. It's in southwest Washington, mountain range in the Cascades. Has periodically active volcanoes. Images include the pre-eruption activity and the post-eruption effects, such as the blast area, the mud flows, the ashfall, and the altered terrain. And I'm going to let you guys click on that and go to that, watch it yourself, rather than making this video any longer. Okay, diagrams of that. You can see the ash cloud here. Like I said, very destructive force. You can see how much, how high it's pushing it up away from the earth. You can see the ash clouds forming. Looks like it's like a rainy day almost. Tree falls and lava flows. So you can see these are all trees that have fallen down from the force of that. You can see the lava flowing down. Same thing here. You see the lava movement. More lava spread. The fume cloud. A lot of very toxic gases build up in these. Okay, and I guess we're done.